John, hey buddy. Pardon the lighting. This is your son's Hotrod Deluxe with the lovely and juicy Celestion A-type speaker in it. Just a great speaker for these amps. I love it. Really good decision on Fender's part. But the amp is in, the amp had a burnt out pilot light. I just threw a bulb in there, no big deal. That is functional again. In the background, let me see if I can get this in there. That hum you're hearing is actually 120 hertz hum that's coming through the speaker while it's in standby mode. And as a matter of fact, the power transformer is mechanically vibrating, and the glassy sound you hear, pardon the wires, is actually the tubes rattling. There we go. These tubes are mechanically noisy. These are old Ruby tubes. Not saying that's the issue, but we're doing this together. And let's see where we're going here. So one of the most common issues with this family of amps, and almost anybody will tell you, and it's hard to capture it. It's hard to capture it here. Let me see if I could break this lamp free without destroying some things on the desk. You might be able to see some around those two block resistors there, and there's a small diode with a little, you'll see a little silver stripe and a black body right next to it. Then there's these two caps here, but right there, if you look where the leads go into the printed circuit board, you'll notice that they're brown and crispy. This is how Fender reduces voltage, and it's a very barbaric method. Instead of having a separate voltage regulator or a separate winding on a transformer to get the 15 or 16 volts that they need for the just to drive the op amps and the relays on board, they use giant resistors, and they're using Zener diodes, two of them. You'll see them flanking this little stack of caps here. They use those Zener diodes as like crude voltage regulators. So if these resistors say, hey, 120, you're going to knock that down to 60 volts, buddy. These Zeners will say, hey, buddy, you see that 60 volts? We're going to knock that down to 16. And they're not saying that, but that's the idea. And what's happening as a result is they're shedding that voltage in the form of heat. And since these components are right on top of the board, there's no air gap, and there's no place for that to go. So it's going to start charring the board. This happens to every one of these. It's just a matter of when. And what's kind of sad is, if you'll notice on the top of the resistor here, let me grab a chopstick. All right, this isn't the coolest one I got, but this is one. You can see a little channel there, and yeah, that can accommodate the leads if you need to bend the leads around, but that's also an air gap. So if you just sit this guy right on the surface of the board, you should have some airflow, and it should be that way on the other side, but I don't think it is. I can't recall offhand, but I feel like this should be facing the other direction. I might be wrong. But even if it were, the issue would still exist. These guys do need to come off at some point, sooner than later, or you're going to have some burnt traces on this board, and then the next guy who opens this thing up to work on it is going to have to do some reconstructive surgery, and it's just going to be ugly. It seldom comes out nice looking. But there's still time. But I'm just saying that it's of the essence. So let's power her up. The caps aren't leaking. These are actually the good Illinois caps. These are the ones that are pretty stout. It's not the old gray ones that you see in the older ones that always end up leaking. But these guys still measure good. And I did not show that part, but let's get this light off, and we're going to be observing this light bulb back here. Let me zoom in. That's the one you want to look at, because I'm going to take her off of standby. First of all, I'm going to switch this amp into that circuit. Now it's in. If I have these meters on that circuit while it's powering up, then it may not show the plate voltage. So I'll have to go through a reset by powering down the amp and then kicking it back on without the current limiter being in the circuit. So it's just the way it works. No big deal. And it's typically not a big deal if you have a tube rectifier that's a slow warm-up. But the solid state rectifiers in here are just, they're quick. They just pour it on right away. They don't need to warm up. So as soon as they hit the breakover voltage, that's it. So, okay, I'm just blabbering on here. Not much time outside of this bit that I've set aside for a diagnosis. Okay, she's on. We're gonna take a peek at this meter, at the tubes, and at the light bulb. You know what, as a matter of fact, let me get this overhead light off. Boop. There we go. Now we can see what we need to see. What I look for is obviously the plate voltage, which is the numbers at the top, are gonna skyrocket, probably jump up to like 420 something. Hopefully the bias stays within 20 to like 40, which is the zero digit at the bottom. I'm also at the same time going to be observing these tubes. You can see the two glowing sections with a dark patch in between. The dark patch is actually the plate structure, and we're going to ensure that there's no red dot forming on that. If it is, then we have thermal runaway. That will also be indicated here and over on the light bulb over there. The light bulb is going to basically run in series with our power, and it's going to protect this circuit from, if there's a short and it wants to pull that extra current out, it's going to face a lot of resistance from that bulb, that incandescent bulb in there. So let's get her kicked on. We'll cross our fingers and toes here. All right. So that's no bueno. All right. Our bulb is dim. Kick her back off. Your bias, let's see. Since there's no excess current draw, we're going to figure out once this is out of the circuit, and it is, what's dragging down the plate voltage and the bias current. Typically, it's an inverse relationship. It's one or the other. And I'm getting not exactly getting a burnt aroma here, but let's start poking around really quick before I have to go, and then I could pick this up after. And that's obviously not a sophisticated test, but sometimes it'll indicate straight away if you have a failing solder joint. So let's get our levels down. I'm getting, so I'm getting additional noise from the preamp. The drive channel's off. Let's get her switched over. Turn the drive up and then the master. I'm getting the same noise through both channels. It's global. More drive. Okay, let's get her down. Phase inverter is going to be out of the question. It should be. Phase inverter is out of the question. This issue's in the power amp, most likely. That'll be a key indicator. So we have a power supply issue, or a tube issue. that we need to rectify. But for certain, get that out of the way. For certain, this is something to look at. I would probably recommend changing these sooner than later because it will be an issue. So maybe consider having me go through. And then while I have this board out, it's not terribly difficult. I can go ahead and ensure that all the solder connections back here by the control panel and all are reinforced. This is a 2009, which means that it doesn't have the lead-free solder, which is a good thing. Let me check something again. Look at that. I wonder if one of these... as the tube warms up, huh? See that? Go through and probe these sockets and go through the whole thing. That's a little, perhaps a little bit of RF noise from my phone because I didn't put it in airplane mode. I know the relays aren't sticking. So, yep, I'll go through there, let you know what I find, and we'll take it from there.